Hello, today we're gonna learn about GUI programming using PyQt6 part 3. In this slide, we're gonna learn about widgets and layouts. So, previously we have learned about Q combo box, right? Here we will learn about QList widget. QList widget is similar to Q combo box, but except that uh, the options that are presented are like scrollable list of items. And unlike Q combo box where we can select only one item at a time, in QList widget we can select multiple items at once. So a QList widget offer an current item change signal, which send the QList item, the element of the list widget, and a current text change signal, which send the text of the current item. And this an example of a QList widget where you can see that we have three items, one, two, three, right? And here we have the signal current item change, which connect with index change method, and current text change signal, which connects with the text change method. So for index change, please remember that it will pass the index, and the index here is the queue list widget item, and when the object is queue list widget item, then we can call text method to return the text of that item. But if it's text change, then it will pass the text of that item. So that's why when we select, we see one twice, because one is from index change and the other is from text change. And now let's see the interaction. Here you can see that when we select each item, then we will see the output on the console as the text of the selected item. Okay, here, if we want to select multiple items, what should we do? We need to call the method set selection mode, and in this method, then we will provide the value as q abstract item view dot selection mode dot multi selection, and then for the signal item click, then it connect with the print item tag, and in the method print item tag, then we use for loop to display all selected items. Here we get all selected items by calling the method selected items. And then we use for loop to go through the index from the first index, which starting from I0 to items dot length minus 1. And then we uh, get each item and then call the function dot text, and then convert it to string, and then append it, uh, and then print the items that are selected, which are already converted to string. So this is the example of the code. From this code here in the init function, you can see that first we're gonna call the init method of the parent uh, of list selected multiple, which here is q dialog. And then here we gonna set the layout as q vertical box layout, so that's why we see the items in our vertical direction. And then we create the list widget object, and then we set selection mode at multi selection, and then we set geometry as like the uh, coordinate xy for the first two values, and the third value is the width, and the last one is the height. And then we use for loop from I0 to uh, 9, because range 10 here is up to 9. And then we create the string item plus index, plus 1. So that's why we see starting here from item 1 to item 10. And then we add that string to the list widget. And then at line number 16, we connect the signal item click with the method print item text. And then we add this list widget to the layout, and then set the layout as the layout that we create from QV box layout. Okay, let's see the demo here. So here you can see that we can select multiple items, and here you can see that the output will print all the selected items. Next, we're gonna learn about QLine Edit. So QLine Edit widget is a simple single line text editing box into which user can type input, and these are used for form fields or setting where there is no restricted list of valid input. The QLine Edit has a number of signals available for different editing events, including when return is pressed by the user, one for when the text in the box has been edited, and one for when it has been changed. Okay, let's see the code and the demo. Here you can see that there are four signals that can be emitted from QLine edit. The first one is return press. When we press the return key, uh, when we have the cursor at the line edit, then this method or this slot is called, okay, return press. And if we press the cursor to select that QLine edit, then selection change is executed. Or if we change the text in the QLine edit, text change method is executed. And if the text has been edited, then text edited is called. So here, as we play with the QLine edit, you can see that different signals are emitted, and we connect to those different slots. So that's why we see different outputs here. Okay, so next we're gonna see the QLine the next widget, okay, which is Q slider. So for Q slider, it provide a slide bar widget rather than display the current value numerically. It's represented by the position of the slider handle along the length of the widget. The most common use of this type of widget is for volume controls. And there is a value change signal that is triggered whenever the value change. And we can set the minimum and maximum value of the slider. Okay, here let's see the example of the Q slider. From this code, you can see that we actually have slider and the value label. And here we have the method display that will display the value of the slider. Let's see the demo here. So here below the slider is the label, and then when we slide or change the slider knob, then the value of that label is changed. And this is because we have the display method here. In the display method, first we print the value of the sender, which here is the slider, and then we set the text of the label, and we convert the value to string and display that. And then we also adjust the size of the label as appropriate. Next, we're gonna learn about layout. So layout management is the way how we place the widgets on the application windows. We can place widgets using absolute positioning or with layout classes. Managing the layout with layout manager is the preferred way of organizing our widget. The programmer specify the position and the size of the each widget in pixel, but if we use absolute positioning, there are many limitations. First, the size and the position of the widget do not change if we design a window, and applications might look different on various platforms. And changing fonts in our application might spoil the layout. And if we decide to change the layout, we must completely redo our layout, which is tedious and time consuming. So here, suppose that we want to move the position of the widget. If we use absolute positioning, then we need to specify like the x value and the y value. Uh, the beginning of the coordinate system is at the left top corner. So the x values go from left to right, the y values go from top to bottom. So if we say hello label dot move 1510, that means x equal to 15. From the left is 15 and from the top is 10. So here this is the example of the using the method set geometry. So just set geometry here specify the coordinate, the location of the widget, and also the width and the height. So here top left of the widget is at x, and uh, from the top to here is y, and this is the width and this is the height. So there are four basic layouts in Qt. We normally want to add more than one widget to a window and have some control where it ends up. So if it's QH box layout, it will place the widget linearly in horizontal direction. If we use the layout QV box layout, it will place the components in the vertical direction. If we use grid layout, it will put in the grid x multiple with y is indexable, and we can also have queue stack layout which stack the widget in front of one another. Okay, so this is the simple window without any layout. So it's just the blank main window, right? You can see that we can create the window by having it as the subclass of Q main window. And here in the ini method, we call the ini method of the superclass which Q main window, and set window title as Q as PyQt6 layout, and then create the app object, and then create the object of the window and call the method show of the window and execute the app. Here, if we want to make some coloring on the window, then here in the ini method, we will call the method set autofill background to be true. And then we're gonna use the palette, the color palette. And the color palette here will set the color uh, as the color that is specified via the argument of the constructor, which is passed to when we create the object, and then set the palette to be that color. So here, after we set the window title, then we call the method set central widget, and then provide the argument color. And here, this will update the color of the window here. So let's understand more about color class. So here in this code, we subclass QWidget, to create our own custom widget color. And then we accept a single parameter when creating the widget with color, and set autofill background to true to tell the widget to automatically fill its background. And if we uh, want to choose the color, we can get the current palette, which is the global desktop palette by default, and change the current QPalette.window color to a new color described by the color that passed in. And then we apply this palette back to widget, and the end result is a widget that is filled with a solid color that we specify when we create it. Okay, let's see another example here. So here we actually say that we create the main window here, right? And then we add the widget with the color red, green, blue. So that's why we see the red, green, blue here. And we define class color in file layout color widget.py. So in this application, we have two Python files. The first one is layout color widget.py, that we create the custom class color, which is the subclass of widget. And then we set color according to the color that is given here. And then we use this color in custom main window here, that we create three colors. So QV box layout will arrange the widget one above the other linearly, fill from top to bottom. So at first we create red, right? So red appear as the top, and then we create widget with color green. So green is the next one, and the last one is blue. Here we can also create the buttons that stack in vertical box layout. So we can create the list of titles like file next, file all, close, and then create the buttons with the title in the list, and then have the layout object as QV box layout, and then add the widget of which are these three buttons. So when we say layout equal to QV box layout, this will create the layout object, and then we can call the method set layout uh, for the layout that we create, and define a list of three strings that represent button types, and then create three buttons from the list types from the list title using a list comprehension. So these buttons are the list of three Q push button for title in the list of titles. And then next, we're gonna add each button in the layout. Okay, next we're gonna look at that. We actually can use the set stretch factor to specify how much the area that we want each component take. For example, if we for the first one, for the red label, we have the stretch factor as 1, and we want the green label to take the space twice as the red label, then we set the stretch factor as 2. And if we want the blue label to take the space as 3 times as the first one, then we set the stretch factor as 3. And we can also setting the space between widgets. So here you can see that if we set spacing to be 10, uh, here we can notice that it will by default the QV box layout set the default space between widgets, but to change space between widgets you can use the set spacing method, and here we set spacing to be 0, so that's why there's no spacing between these widgets. And we can also set the content margins. So yeah, if we want to have like the content margins of the layout with the nearby component, like at line number 19 we set margin uh content margin as 0, 20, 10, 40. This mean like left, so left is 0, so that's why we don't see any spacing here. Top 20, right 10, and the last one is bottom. Top this left, top right, bottom. Okay. And for QH block layout, it will uh, arrange widgets in horizontal direction, fill from left to right. And we can also have nesting layout. You can add the layout in another layout. So let's see the example. Here we have layout 1, 2, 3. Okay. So layout 2, add the widget red, yellow, purple. And then layout 1, add layout 2. So uh, these two the first two column here are in layout 1, and in layout 1 the first member is layout 2, and the second member is the color green, and then layout 3 is the layout at the last column, which has color red and purple. And then here layout 1 add layout 3, so that's why layout 3 is the last column. And then we set the entire layout as layout 1 as specified in line 38. And here we can also set spacing between layout, like layout 1 we set spacing as 20 and set content margin as 0, 0, 0. So that's why it's like no spacing from top, from bottom, from left. And then next we're gonna see alignment. So when the parent widget has more space for child widget, the child widget will stretch horizontally like this. It will take like the equal spacing. So here we have 3 buttons, right? Yes, no, cancel. So here we add the widget of these 3 buttons in buttons layout, and button layout we have it as QH box layout. And then the overall layout we have line edit as the first widget, and line edit we set minimum width at 300, and then add line edit in the layout and add buttons layout in the overall layout. But here if you want the widgets to be aligned left, then we can say button layout dot add stretch. So this, when we call the method add stretch, it will add horizontal spacer to the end of the layout. On the other hand, if we call add stretch before we add the widgets, it will add the spacing before the first member in the layout. But if we want to have it as center, uh, then we can add the spacer at the beginning and at the end. So here we can see that we call the method add stretch at line number 15 before we add buttons, and at line number 21 after we add buttons. Next, we're going to learn about QGrid layout. QGrid layout allow us to place widget in uniform rows and column, and we can specify row and column position for each widget. and we can skip elements and they will left empty. Usually for Qt layout, we don't need to fill all the position in the grid. So let's understand about the grid position. So the top left is 0, 0 because the first row is has the index as 0 for the first number, and for the first column it has index as 0. So if it's the slot at the second column and second row, that's why the index is 1 1. Okay, so again layout with unfilled slot. So here we have like filled slot, only 4 slot, and the rest is unfilled. So this 0 3 because it's at the first row, right? First row has index 0. And it has index as 3 because it's at the fourth column. Remember that the index starting from 0. And this the at the second row, second column. So that's why the index is 1 1. Third row, third column, index is 2 2. Fourth row, but first column, so the index is 3 0. So rows and columns are zero based indexing. It means the first row has index of 0, the second row has index of 1, and so on. Similarly, the first column has index of 0, the second column has index of 1, and the intersection between a row and column is called a cell. So a cell is a space where you can place a widget. So when we use Q grid layout, we need to specify the widget and the row column that we want to place that widget, and row span, column span, and alignment. So row span is optional, which is the number of rows that we want to span. Column span is also optional, is number column that you want to span. And alignment, it means specify the alignment of the widget within the cell. Okay, let's see the example here. Here we create the grid layout and we add in color red as 0 0, right? Uh, and then add green at 1 0, and add purple as 1 1, and add yellow as 2 1. And this we use the Qgrid layout to create the login form. So here for the login form, here we have label username as 0 0, line edit for username as 0 1, password as 1 0, and the line edit for password at 1 1. And then next one, we gonna add the Q push button, right? The Q push button here for the login, it will align left, and clear will align right. And here, if you want to create calculator, we can create the list of the names of the buttons, and then at the position, then we place the Q push button with that name in the Q grid layout. So here range 5 means 0 1 2 3 4, and position starting from 0 0 0 1 and so on until 4 3. And names are the names of the buttons. And when we say zip position name, it will match the coordinate with the name, right? With the name of the button. So here button equal to Q push button name equal to Q push button clear, right? And then when we say Q add widget button star position, uh, it will get the first pair 0 0 for the first button. And this is the example of using column spans. So here we want the whole line to take many columns. So in text edit 4, we specify that here column span is 3. And alignment flags include like align absolute, baseline, bottom, center, and